Hi gang, I hope your test went well today. I'll do my best to try to have those back to you as soon as I can. For now, what I'll do is explain to you these warm-up problems, and we'll then talk about some other problems that you may see in your homework assignment tonight, which will be the first assignment, assignment number 1, from the next assignment sheet. And then I'll be back with you again tomorrow. So let's take a look at this. Just a little bit new notation. D over dx, this is just the action of taking a derivative. So no big deal. You know how to take the derivative of this. Derivative of 3x squared, of course, is 6x. Derivative of 2x is 2. And, of course, the derivative of negative 1 is just going to be 0. Then over here on the right-hand side, again, you see that same derivative notation. Just says take the derivative of what comes next. And we've got a little problem here. We've got a fraction, and so we're going to need to use the quotient rule. And so that looks like low d high minus high d low all over low squared. And so there's no need to simplify the denominator. Let's just simplify the numerator. That looks like x squared plus 2 minus a 2x squared. And then finally, negative x squared, or 2 minus x squared, all over x squared plus 2, the quantity squared. Don't forget that would find for you the slope of the tangent line. It could find for you instantaneous velocity. Lots of different applications for the derivative. Next, we want to find the derivative at negative 1. So the slope at negative 1 is found by, first of all, let's just take the derivative of this original function. We get 4x minus 8. And then we'll just evaluate that at 1. It looks like 4 times 1 minus 8, or of course, negative 4. And so that might be the slope of the tangent line. Again, it might be velocity. Alright, so the reason that I wanted to see those warm-up problems is so that you would understand what this notation was all about. Basically, it just says that we want to find the derivative of sine of x. And so today, we're going to start talking about finding the derivative of trig functions. And before we find those derivative of trig functions, I want you to see what a trig function is, and I want you to not just see it, but I want you to hear it also. And so if you listen carefully, you will be able to see the difference in the frequencies here. This is like one of those sound tests or hearing tests that you would have had back in elementary school. So if we increase the frequency, that's what happens. Now decrease the frequency, increase it again. So what if we change the amplitude of a trig function? This is what it sounds like. Increase and decrease that amplitude. And so that's what happens with those trig functions. Now that's kind of a static trig function. The question is, what would a dynamic trig function sound like? So back in trig class, all you had were static trig functions. Now we want to talk in calculus. What happens when you change those trig functions quickly? What might that sound like? Sorry about that, a little technical glitch. I'm a first-timer with this. We're doing our best. Alright, so how do we go about doing this? Our job is to find the derivative of the sine of x. And what we're going to do is we're going to try to do this with the calculator. So go ahead and get out your calculators. And let's take a look at those together. I'll pull up my calculator here so that we can look at this together. Let's just go to y equals. And let's clear out what's there, top and bottom. And let's go ahead and go to the sine curve. So go ahead and graph sine of x. And let's zoom and trig. Let's go ahead and take a look. Zoom in 7. See what that might look like on our graphing calculator. Okay, and so hopefully you have something that looks like that. Now, one of the things we could do with this is we could come over here and we could start graphing the derivative. We know that the slope is 0 at this place, at this place, at this place, and at this place, and so I could graph the slopes on the x-axis at each of those places. And so that might look like this, 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 and this. And then I can see that my slope will be positive here, negative here, and so starts off positive, then goes negative but connects again, then it is positive again. And so the question is, what's the graph that we're creating here? Well, some of you might have a guess already, but let's go back and take a look at the calculator and see if we can find out. Okay, so let's go to y equals, and in y sub 2, let's go ahead, and those of you that have the new TI-84s, you'll be able to follow along with this. Those of you that do not have the TI-84s, just wait patiently, and I'll do my best to try to explain to you what you need to type in. So everyone at this point, let's go ahead and go to Math and 8. If you go to option number 8, you will see n-deriv, which is what we want in that spot. And so let's go ahead and click on that. Now, those of you that have the TI-83s, again, you'll have n-deriv in this spot, and I'll show you just in a minute what you need to do. But for those of you that have the 84s, let's go ahead and put in an x. So d over dx, similar to that notation we had for the warm-up today. And then in this spot, let's go ahead and use vars, y vars, function, and y sub 1. And then use your right arrow key to get to that other spot where instead of finding the derivative of the function at x equals pi or x equals pi over 2, let's go ahead and do it at x equals x, or for every x value. Okay, now those of you that have the graphing calculator TI-83s, here's what you're going to need to do. For y1, you already have sine x in there. For y2 though, let's take a look down here and let's go ahead and just put this in for y2. Go ahead and you have n-deriv already, and so then it opens up a set of parentheses for you, and behind n-deriv, now you want to go through the keystrokes to create y sub 1. And so remember, that's vars, y vars, function, y sub 1. You want to put a comma, x, with respect to x that is, and another x, and then close parentheses, and you will end up getting the exact same thing that we get. Okay? Notice that on my graphing calculator I have it in bold, y sub 2 is in bold, and so you may want to make yours bold as well so that you can see this graph a little bit easier. And you can just go ahead and scroll over to the left-hand side, and you can just hit enter a number of times and you can change it to whatever you'd like. So let's go ahead and zoom in trig and see what happened here. There's my original function, and here comes the derivative, much like what we graphed before. Aha! And so your suspicions were correct. What does that graph look like? If you said this graph looks like, or the derivative of sine x is, right here's the graph. That graph right there is what? You guessed it, cosine curve, right? And so we have the cosine of x. Go ahead and do the same thing with cosine and see if you can come up with its derivative. And I'd ask if the substitute could just pause the video. I'd appreciate it. Okay, things have changed here a little bit. Now we're looking at the cosine function instead, and so we graph it. There's the cosine function. So who is his derivative? There you see it. Hopefully you pick this one out. So the derivative of the cosine of x. Now we're looking at the derivative of cosine of x. and the derivative of cosine of x is what? Now be careful. Some of you shout out sine x, but notice this graph is not exactly sine x. In fact, what would sine x look like? Sine x would look more like this. And so what's the difference between those two? Notice that sine x is there, but this graph that we're talking about is the opposite of sine x, so negative sine x. Now, if there's still time, I'd like you to watch the second video, but if there's not enough time, then go ahead and just see page 138 in your book for all 6 derivatives of the six trig functions, easy for me to say, and then go ahead and work on that assignment for tonight.